Hi, Jessica here. Today I'll be talking about the potential benefits of a cool roof installation. So after completing the cool climate calculator, I realized that my home used 72 more electricity or energy costs compared to most of the other homes in my area. I was just wondering why my electricity usage is so high and possible ways as to how I can reduce my electricity use. So after going or searching through National Grid and investigating, I found out that during the summer months, my electricity use was significantly higher than compared to the winter months. So I assumed that it was due to air conditioning usage. And as you can see here on the left, this is a satellite view from Google Images of my current home roof, and the dimensions are 25 by 40. After doing some research, I stumbled upon metal cool roofs, which are slightly different compared to green roofs and require a lot less maintenance. So I thought this would be a cool action to pursue. So metal roofs hold up well in various climates and resist corrosion from natural elements, so they are very durable. They also have a high solar reflectance rate and can reflect up to 70% of the sun's radiation. This in turn decreases the internal temperature in your home during the summer months because it's decreasing the heating load that a normal rubber roof, a normal dark rubber roof would possibly usually retain. Metal roofs are also fire resistant, low maintenance. Actually, almost no maintenance is required after installation, and they have a long life expectancy of up to 50 years. So my current rubber roof is very durable and weather resistant, like from water and rain and hail. It's also fire resistant and has low maintenance costs as well. And so one of the reasons why we installed a rubber roof was because of the low installation costs and a long life expectancy as well of up to 40 years. How exactly do cool roofs work? So cool roofs are able to keep the home cool during the summer months by reducing heating load. The high solar reflectance of the metal reduces the heat gain of a building. When heat gain is reduced, the building is able to maintain a cooler internal temperature and hopefully reduce air conditioning or cooling usage. The goal of my project is to reduce my yearly electricity consumption. The scope of my project will be a scenario comparison of my business as usual electricity usage of 1 year and the installation and reduced electricity usage of 1 year. So here we have my functional unit and reference flow. The reference flow will be business as usual with electricity use of 1 year, and the second reference flow will be reduced electricity use of 1 year with the construction of the aluminum roof. So here we have my system boundary. My system boundary will be considering raw materials, extraction, and energy waste, and the entire installation and roof production process is only considered in the alternative. Meanwhile, in my business as usual, only electricity is considered. Some foreground modeling I had to do was to find out the expected reduction in cooling after installation of a cool roof, which is expected to be 10 to 15% after installation. But the 10 to 15% is only a reduction in cooling costs. So in order to calculate this, I went on the 2015 EIA survey and found that 17% of electricity is used on air conditioning, and air conditioning is basically only used for cooling. So I needed to calculate projected electricity usage after installation, and I based my calculations off of these numbers. Various other calculations were also done for the assembly of the aluminum panel roofing, and that will be discussed a little later. Here we have a chart of my current electricity usage as of 2020. The blue bars represent total electricity usage per month, and the white bar represents total AC usage per month. I understand that in the winter months, AC usage might not be or should not be calculated, but because the EIA data provided was based on a yearly basis, I just divided everything by 17%. Here is the chart for the expected energy usage after installation of the aluminum roof. The change may not be drastic since it's only 15% of a 17%. And so here, I'm not sure if you are able to see too clearly, but there are slight decreases in the AC usage compared to actual usage in 2021. Here is the expected energy versus my current energy usage. As you can see, the red dotted is the expected energy usage, and it is slightly lower compared to my current energy usage. So some of the calculations were based off of my home dimensions, which was needed for the aluminum data. And for aluminum data, I had to do some research as to what my desired thickness is and what would be a good thickness for a aluminum roofing, and it was approximately 0.032 inches. And from that, I calculated the mass which was needed in EcoInvent. And I also did some other wood data calculations, transportation calculations, and nail calculations. So here's my reference flows. As you can see, the first reference flow right here is business as usual, and this only accounts for the electricity, and I chose electricity low voltage at grid, and this is my own personal value usage in kilowatts per hour. And over here on the bottom, this is the second reference flow, which would be the installation of the aluminum roof and yearly electricity usage. So the electricity usage here is the expected electricity usage, which I calculated earlier from the potential benefits percentage. And the aluminum was calculated based off of my home dimensions. The only thing that might be a little odd would be the transportation method. I decided to use transportation passenger car because that would be the type of or the vehicle I would be using to pick up the items, and I just divided the materials by the weight of an average person, which was 131 pounds based off of Google, and I multiplied that by persons per mile, and that's how I got my value for transportation right here. In the results, I received some information that was a little different from what I was expecting. In two impact categories of carcinogenics and ecotoxicity, I actually received negative results in the benefits section. So I'm assuming business as usual would be preferred over the construction of an aluminum roof. However, in other sections, I did receive a benefit, and in order to get a positive result, I would have to repeat these actions multiple times, more than I was expecting, actually. As for uncertainties, expected electricity usage with a metal cool roof was based off of EIA statistics, and the calculations are all projected, so there may be certain uncertainties there. And as for heat loss, there may be heat loss that can occur after the installation of a roof, but I felt that in my case of this project, it might not happen since my installation is not new, but it's on top of a current existing roof. So I'm assuming heat won't be lost because there is still that rubber roof underneath. And there may be certain uncertainties in numbers due to the impacts of substituted machine processes for actual machine processes that are unavailable on EcoInvent. And most of these calculations are based off of my personal electricity use as opposed to a whole household. And I think that overall impacts of a roof construction may be lower or different if an entire household was taken under consideration. From this study, I've concluded that the construction of a metal roof will have to be done approximately 366 times to have a benefit towards global warming, as you can see highlighted over here. And to create a handprint, numerous people will have to build a metal roof to offset most of the impact categories needs. And actually, after doing this project, I'm thinking that maybe building a metal roof may not be as beneficial if we are trying to meet short-term goals in reducing impact categories. And possibly more studies can be done in the future to reduce electricity usage, and maybe metal roofs would be more influential or have positive results in countries that don't necessarily have air conditioning usage and can lower internal temperatures in general. Thank you so much for listening.